ethanoic acid or acetic acid. The formula of ethanoic acid is CH3COH. So let us see some of the application of ethanoic acid. So 5 to 8% of ethanoic acid by volume. Volume means in 100 ml of water, 100 ml of solution, 5 ml is ethanoic acid, and remaining ml is your water. So this is called this solution is called as vinegar. Boiling point of the ethanoic acid is 118 degrees centigrade and melting point of the ethanoic acid is 16.6 degrees centigrade. Why it is important melting point of ethanoic acid? So at room temperature, so this is just like a room temperature. So at this temperature what happens, this ethanoic acid is it freezes down to become a colorless ice-like crystals, and this ice-like crystals is called as glacial acetic acid, and this is very pure and anhydrous ethanoic acid. So just keep in mind, and this is used for freezing the ice creams. All these things are used here, used by the glacial acetic acid. Now let us see the chemical properties of ethanoic acid. So in chemical property ethanoic acid, you can see here, so CH3COOH, this is CH3 is a formula of ethanoic acid. There are three type of reactions take place by the ethanoic acid. One, removal of hydrogen, one removal of OH group, and third is the application of use of this whole acetic acid compounds. So reaction involving cleavage of OH bond. So here what, first this bond is cleaved down, second time this bond is cleaved down, and third time whole molecule participate in the reaction. So first we will see one by one. Reaction involving the cleavage of OH bond. So in OH bond, reaction with metals and alkali. So here the acetic acid react with sodium Na2CO3, sodium bicarbonate, calcium hydroxide. All these are weak base. These and sodium is a strong base. So they will evolve carbon dioxide. That's why this reaction is used for detection of carboxylic acid group in the organic compound. This acid is detected by using this type of reagent. How? This is the formula of acetic acid, where R is the any unknown group like CH3, CH2, anything you can take it. So when you react with the base sodium, so what happens, this hydrogen is converted to hydrogen gas. So if this is converted to hydrogen gas, and there is a formation of salt, and this is a commonly reaction of acid and base reaction. So we know that sodium is the base, and automatically this will become acid because hydrogen gas is released, and this we can understand through the pop sound. Now second is acetic acid plus sodium carbonate. So this will react, this will remove this hydrogen, and it is given sodium salt, and plus CO2. This CO2 is given up as a brisk evaporation. So this is readily immediately converted. It will form a bubbles in the waters and come out. So this bubbles is nothing but the CO2 gas. So this is the one test for presence of carboxylic acid in solution. Next is your acetic acid plus sodium bicarbonate. Same reaction, sodium acetate plus CO2 will form. So this will also it is a test for detection of carboxylic groups. Same, if you take calcium hydroxide, all these are mixed. Here we will get two molecule acid because calcium is a divalent compound. So we will get one molecule, two molecule of water. So calcium acetate plus water. Now next reaction you see, reaction involving cleavage of COH bond. So here I am taking ethanol. So ethanol we have previously seen, if acetic acid react with ethanol, so from ethanol in concentrated H2SO4. So this reaction is a reversible reaction in which one H from the ethanol and one OH from the acetic acid is converted to water, and these two reactant will become one product, and this is called ester. So this is your ethyl acetate. This is ethyl, and this is called acetate, ethyl acetate. So this is ester, and you know ester gives you a pleasant smell, very good smells. Normally in fruits we are observing that they are having very good smell. So these are the actually esters. Now next reaction is the formation of your anhydride. So if you take two molecule of acetic acid, this is here, you see here. So one OH from here, one H from here. So if this reaction takes place in presence of concentrated H2SO4 or phosphorus pentaoxide, and if you heat it, so this water will be released, it will be converted here, and this oxygen combined with this carbon. So we will get acidic anhydride. So here again anhydride means loss of water. So these two acids combine to become a anhydride. Anhydride we know children, CH3COO, oxygen in between, and two sides is same group is there. This is called anhydride. So anhydride is the functional group. So this is also we can make product from the anhydride by removing the OH. Now third reaction involving acetic acid as a whole molecule. So one reaction by hydrogenation. So in hydrogenation, this hydrogen is totally attached with the carbon in presence of nickel as a catalyst, and we heat it. So we will get here CH3 and we will get water here over here. Similarly, we can use one more product, that is acetic acid plus lithium aluminum hydride. So in lithium aluminum hydride, so here this will give you hydride and H negative. So this carbon will give one H negative and one water, one H plus will get from here, and this H2 will release as a water over here. So we can say CH3CH2OH. So what is lithium aluminum hydride? So this is a very strong reducing agent. It transfer hydrogen to carboxyl carbon. So this is the carboxyl carbon. So CH3COOH. So actually here one hydrogen attached, here one hydrogen, so one bond broken. So again one more hydrogen and one more hydrogen. So this will be reached as a water, and this will be again H plus is there. So again so this will be water, so this will be CH3CH2OH. So we will get here ethanol. Now next is your reduction of formic acid. HCOH called as formic acid. So formic acid has some reactions I have given you. So these are the reactions are, we can see. So in this reaction, formic acid, so under the 433 Kelvin high pressure, this is converted to CO2 plus gas, and this is called as decarboxylation reaction. Decarboxylation reaction means removal of carbon dioxide from the reactant. If you take concentrated H2SO4, it will give you CO plus water, and CO, you know, if you burn it, if you heat it, it will burn with a blue flame, just to mark it. CO2 will give you a colorless flame, no flame. It does not burn. CO2 does not burn, as you know very well. It does not burn, but CO burn, mind it. And carbon monoxide, if you give you this formic acid in presence of oxidation reactions with the help of oxidizing agent, so it will convert it to CO2 plus water. This, you know, any hydrocarbon, if you give oxidation, it will give you final product CO plus water. So just learn this reaction. Concentrated H2SO4, water released, but if you give this temperature 433 Kelvin, so you will get CO2 plus hydrogen gas. Now we see comparison of ethanol and ethanoic acid, how we can compare it. So if you take smell wise, so ethanol is the pleasant smell, but ethanoic acid is the vinegar smell. Vinegar, you know, taste is, ethanol is like a burning taste, but acetic acid give you a sour taste. With litmus paper, ethanol give you neutral, so there is no effect of litmus paper on the ethanol, but acetic acid, they will convert blue litmus to red litmus. If you take sodium bicarbonate, there is no effect of ethanol in with the help of sodium bicarbonate, no reactions, but acetic acid, we know this is a detection of carboxylic acid, so immediately CO2 briskly come out in the solution as in the form of bubbles. This is called effervescence. So this is the test for carboxylic acid. Test for carboxylic acid. So okay, so we'll go for next topic.